没办法。
你们都没有问题，相信的啊。我们在这个如此艰难的这个夏天还能坚持学习，那么我相信我们在座的同学肯定都没有问题啊。毕竟毅力也很重要嘛，你们都很有这个毅力和魄力啊。
都得懂一些，然后程序员更是，程序员说实话什么都得懂，
哦，
不
你
懂。
如果当 coding 的人的话，我其实说咱们学 CS 的人，其实我告诉你，学 CS 其实挺辛苦的。为什么？我不跟你讲吗？你光学计算机语言，你就能学好多种语言。计算机语言太多了，
对
你要学好多种语言啊。然后安全方向的、security 方向的、website 方向的，然后好多的。然后呢，这个 database 的，然后呢，这个数据结构的 structure 的，然后呢，这个总之还有图像处理的这种，反正没事，我一年轻人就要永远充满 security，curiosity 就好奇心嘛。然后呢，不断的去学习，加油。
OK， 好的。哎呦，看人差不多到齐了吧？差不多到齐了7个。OK，那我们现在开始上课吧。Alright，一个代码还有设计是呀，怎么说呢？就各方各面的都得懂一点，不懂就得去学，咋办呢？好吧，那好，那我们开始 today's lecture，好吧？那么昨天讲了什么？昨天讲了 sequence in Python，对吧？有string，有 list，有 tuple，对吧？那 tuple 和 list 的主要区别就是list 是 flexible，然后 tuple 是比较 fixed，right？So yeah, like once you announce or once you have assigned to a tuple, then this tuple cannot be changed after you have created it. Okay, and then indexing in the subsequence, those works the same for tuple and the list. So yeah, you can use them the same way, and I think that you should be pretty comfortable by like looking at those indexings right now, because like those are one of the basic stuff that you need to be pretty familiar with. Okay, addition and multiplication just means you can add two tuples. You can add two tuples. You cannot add a list and a tuple. Okay, and then yeah, if there is only one element in tuple, a comma is needed to be added, because when you simply add a bracket, then just treat it as a normal stuff, because the bracket does not do anything. But for one element, if you add a comma, then it actually knows that this is the notation for tuple. Okay, and then the in operator, I've talked about it a lot of times. As long as that is like a tuple or a list or a string, then you can just use an in operator to check if something is in that specific list or tuple. Len, max, and main. So you can pass in a tuple or a list into the max function, right? And for max min, for it to get compared, the tuple in the tuple, every kind of every element has to have the same data type, right? Either have to be like int or string or stuff like this, or yeah, maybe float. That can be true as well. But yeah, normally we would do this. And then max, in terms of numbers, we just get the largest number. Min for numbers are just um, the minimum number. And for a string, just refer to the ASCII table, right? The lowercase letter is larger than uppercase letter is larger than numbers. Okay, yeah, so just remember that order. And if you don't remember it, as it is okay. As programmers, we always look up things. We don't put everything in our head, as long as we know where to look for them. All right. So yeah, that is that. And then len, that's easy. You can just get the length of a specific tuple or a list. All right. So yeah, this works the same for a list. I'm not gonna repeat myself. Sequence packing and unpacking. So this one is pretty important. Yeah, you can pack, for example, three values into one variable, and the type will be a tuple, right? And then if you do unpacking, if you have like three variables, and then you assign those three variables with a tuple, then those three variable just be automatically assigned by itself. So this is called unpacking. Okay, and then you can pack in them again, right? So more vowels is equal to like A, B, C, D, and then it sort of packs those four values into more vowels. And then with packing and unpacking, what we can do is do something like this. And at the first glance, you might say, yo, this makes sense, right? And it actually does make sense. So 10, 20, 30, it just makes into a tuple using the packing technique. And then that tuple is further assigned to three variables, right? So you sort of unpack it. Yeah. So after you unpack it, x is equal to 10, y is equal to 20, z is equal to 30. All right. And also we can exchange the a value of variable by using this technique, right? So xyz is equal to zxy. Then you print them. You will find out, the variable have different order, right? 30 is now into x, 10 is now into y, and 20 is now into z. Right. So with this packing technique, you can also what you can also do is you don't unpack everything, right? You only unpack a specific or a certain number of elements. All right. So you can do first, second, and then this star here makes variable into a list. So that means that we have this first and second, and then the rest. And then after you unpack it, then the first element is just first element, second element is the second, and then the rest is placed into a rest. The format is remain a list. Um, yeah, so that is the idea. And then you can also do something like begin, right? And then begin last, and then it just takes out the last element, first, middle, last. Takes the first, takes the last, leave the rest in there. Yeah. And as we come to list, then a list, you have this list function, and then you can pass in basically a tuple, then you can convert it into a list, right? And you can yeah, just for completeness, you can do the same for tuple, right? You pass in the list, and then try to make it into tuple, right? Then here's the tuple. Okay, and then you can also do list, make the range function into a list, right? That one, not gonna talk too much about it. C list, yeah, you can also do like pass in a parameter for the range so that it actually skips have a step value that is 3 or 4 or whatever you want. Okay, so list, append, extend, right? This one is the one that we use most often, right? So you can have a list, and then you can further, sort of add add elements into it, right? Um, and then when you append, you just add to the end of the list, right? Like the index is just the length minus 1, right? And then you can just append whatever you want. You can also append a tuple or a list. And then if you use append, then it will treat as like one element, right? So like, for example, if you append it there, then the list element, for example, the index 5 is just a tuple, right? And then yeah, so like you might not know what is in the tuple, or you might know, but like it is treated as a whole, right? Okay, so it is the same for those, for a list. And then if you have a list in a list, it is okay. Yeah, so it also just treated as one element. Okay, so yeah, every time you append, it just treated as one element, no matter what you provide in there. All right, so that is the feature of append. Okay, but extend means it actually takes whatever that you provided, and then takes each element and put it in the list. And for example, you have those 3 elements, right? And then it does not it is not being treated as one object. It is not treated as one element. It actually treated as 3 elements. And the same for this extend range function. It actually treated as 4 separate elements. But if you try to extend the list with like a list in the list, or like a tuple in a tuple, then it only unpacks the first layer. But I mean unpacks the first layer, I mean that 0.2 is making it into elements. This whole thing is making it into elements, right? And then this is another element. So at the end results, you can still see a list in a list, right? But this is already been unpacked and also treated as one element. Yeah, so you can delete list and tuple elements, and then you can do that even for normal variables. So yeah, if you delete b list, the first index, then this 5 is deleted, right? And then you delete b list by step 2, then you just erase half of the list. Okay, so yeah, normal variables like name, and then you assign a name, and then you just delete that, and then if you try to print that, it will give you an error because the compiler thinks that name is never defined. Okay, and remove function. Uh, remove function just gives you the idea. It is just to find this specific thing that you're looking for and remove it, right? But it only removes the first instance of that content that you provided, right? So yeah, and then if you try to remove again, then it will remove both of the 10s. And then if you don't have that in the list and then you try to remove it, then it will give you a key error. Okay, so yeah, I don't know what you're removing. Whatever you're removing, it is not in the list. So go somewhere else. All right, yeah. And then the other function is clist.clear. So it just clears the list. Okay. change, it is hidden somewhere. Yeah, change the value of an element in the list. You can directly go to the index and change a specific value. That is what we usually use, and that will be used the most. Okay, so the list will be a list of range from 1 to 6, and then you can change them by a list of index and then exchange those into, like, for example, 1 2 3. And you can probably notice that by I mean 1 is 3, b list, we are replacing two elements, which is 2 and 3 here, by like actually 3 elements. And in Python this is okay. All right, so yeah, you don't have to be like really strict. You might think that the if you're replacing two elements, then you have to provide two elements, but like that is not the case for Python. You can even do this, and then 2 to 2 does not actually mean anything. It actually means like you start from 2 but not include 2, so that is a bit weird. But the idea is whatever you're inserting, like the first element that you're inserting has the index 2 in this case. All right, yeah, so 0 1 2, right? And yeah, this is the case. Yeah, you can also delete it like this. It is practical, it is faster than you actually do like del and then b list 2 and b list 3 and b list 4. So yeah, that is just a simple way to delete it. And then if you put it in a string, it automatically makes it into a character list. All right, so yeah, treat this as a 3 elements list, and then you assign it there. So yeah, other useful functions, count just means how many times one variable appears. Index checks the index of an element. Pop uses a stack. Reverse, you can reverse the entire list. And sort just means sort the elements. All right. And yeah, count is this. Just count one specific thing and it will give you a value. Index just means if you have this, then it will return the first occurrence of the index. And you can specify where do you start, right? This is the starting index 1. And stack is the fun one. You can use it as a stack. You can try to append and you can try to pop, right? And that is what a stack do. Think of a stack of books, right? And you can only see the first book, right? And then you can just keep pushing more books onto this stack. And then when you try to remove it, then yeah, the idea I forgot to mention yesterday was this is called last in first out. So short for that is called LIFO, right? So means last in first out. And you think about this, the things you put into the last, right? So you do like append 1, append 4, append 5, right? And then the last one you append in is 5, and then print stack pop. And then if you try to get it out, then the last element that you put in is the first element that is get out from the stack. All right, so yeah, remember this kind of feature, last in first out. And there is another kind of data structure. Since I mentioned this, it is called queue. And this feature is first in first out. All right. So yeah, that means thinking of you're going into, for example, McDonald's or Coco, right? And then you're actually waiting for the queue. Like it does, like it would make sense that arrive whoever is arrived first be served first, right? So like 先来后到嘛，对吧? So that is called a queue, right? So it is first in, first out, right? So the one comes first, being served first, and then gets out first. All right, so yeah, that is a little bit side knowledge. Sorry about that. Yeah, you can actually we can actually look into that later in the course. All right, so those data structures are actually useful and fun to deal with. All right, so yeah, that is stack. Yeah, reverse, just reverse the list. You can you can use this to actually reverse a string. Yeah, so that is the good use of it. And then you can do sort, but be careful if you don't have same, like if you don't have same type of elements, then you cannot sort it, or you cannot sort it for now. All right. Yeah. So you can have a key for sorted, and then that is when you specify um, what to sort, right? You're sorting by what, right? So in this case, you are sorting by the length of the array instead of the actual ASCII value of the array. So yeah, that is something to keep in mind. And exercise. All right, so that is time we talk about exercise. Have you all done the exercise? Um, yeah, if you have all done the exercise, then probably type something, right? Give me some feedback about how exercise it is. I feel like it is not that difficult, especially yesterday compared to like the previous. I got confused on question two. Yeah, remember yesterday I mentioned, wait, question two is this one, right? Like compute the sum of all elements. Is that the one you got confused on, or the permutation one? I think the permutation one, I might agree that is not a extremely good exercise, but it is sort of gives you a little bit of research experience about like looking up the libraries. There is a library to do permutations. I did not mention it. I hope that you guys can, sort of research on your own, and then actually find the answers by yourself. All right. So yeah. Without further ado, let's actually get into it, and I will tell you my solution. And if you want to share your solution, feel free to do so in the chat. Okay. So write a program, convert a given string list to a tuple, right? So yeah, original string is 3.0, Python 3.0, and then the class is string, and then convert it to a tuple. And then yeah, interestingly, you can just use this tuple function, right? You do not even have to convert it into a list to do that. You can just directly take a string and then use this conversion for tuple, and then input a string, and then July 13th. And then you just basically separate them all into like specific characters. So yeah, that one is easy. That one is just 2 lines of code. So I am assuming that you guys don't have any questions on this. All right. So yeah, the second question could be, I would say that it is the most difficult exercise among yesterday. So yeah, I'll actually go through it. So write a Python program to compute the sum of all elements, right? And of each tuple stored in a list of tuples. And what that means is you have a list, and then every element is a tuple, right? And then you need to get the sum of each tuple, right? So for example, if the input is in this case 1 and 2, right? And 1 and 2 maps to this 3 because 1 plus 2 is 3, right? And then 2 and 3, the sum of this entire tuple is 5, right? Because 2 plus 3 is 5, and then yeah, 3 plus 4 is 7, right? And then you can have different ones. So original list of tuples can be this. You don't have to be like fix the length of tuples or fix the number of elements in tuple. Like those does not matter for us as a programmer. Yeah. So original list of tuples is 1 to 6, and then to blah blah blah. I believe that you have seen this. Sum of all elements of each tuple stored in the sum of it will be 1 plus 2 plus 6, which is 9. 2 plus 3 plus -6 is -1, and 3 plus 4 is 7, and then 2 to 2 just gives you 8. So yeah, how would you do this, right? Any kinds of any kinds of concerns, like, or after I have explained the exercise, what are you thinking, or what is the specific thing that you're stuck on? The question itself, or like you do not know how to approach this? Questions, concerns? Yeah, it is the time now that you actually try to address what is that you're confusing or you're having difficulty with. So I can help. Or if you guys don't want to share right now, I can actually review the answer first, and then see how that compares to your solution. All right, I guess I'm gonna just go ahead and share the exercise answer. So yeah, I just punch in those inputs. Yeah, so it can be really any inputs, but like I just don't want to actually deal with it using like an input method. All right, but yeah, those are 2 examples. Feel free to change those variables so that your program is not just only developed for those specific inputs. But yeah, here is the thing. So this is when you actually look at the program or the code itself, this seems to be pretty reasonable, right? And the first loop, so this is using the idea of nested loop, right? So you can have a list, and then for I in A means that you are taking every element in the list A, right? And then what? And if you are actually if you're actually not sure what are those, then you can actually print I, and I will just demonstrate you this. So yeah, if you try to print I, then you will get this, right? So you will get 1, 2 as as the first element, 2, 3 is the second element, 3, 4 is the third element, right? And then after you get this, you can have a sum. You can have a variable called, for example, a sum, right? And then this is just for calculating the sum for each tuple, right? And then you just again loop through for j in I. So I in this case is just 1, 2, 2, 3, and 3, 4, right? And then for j in I just means for every element in each of those tuples, right? So if you actually print out j, then you will have like 1, 2, right? And then for the second iteration, you will have 2, 3, right? And then you plus or equal this you use a sum plus equals to j. That means that you are accumulating the answer of j onto a sum, right? And yeah, this actually sums up all the value uh, in the tuple, and then you can have a result array, right? Or a result list. And then after you are done with each tuple, then you just append a sum, right? And if I just uncomment this, then if I run this, then you can see the first loop, and then after I print a res, gives me 3, 5, 7, and then I basically did the same for b as well. I just changed the variable name, so it is the same algorithm really. So if you input this b here, then it actually performs all the sums. All right. So yeah, in terms of question 2, is there any questions, or is there anything that you still do not understand? I mean, the idea of this list in a list, right, or tuple in a list, can be, you know, a little bit challenging when you first start looking through this, but you know, I mean, after you deal with it again and again, like, yeah, when you write some code, you have to know what kind of data that you are dealing with, right? And you know, one thing I do not like Python is that you know, the variable can be uh, any type, right? And then that sometimes will get me confused. So you have to like be really clear of you know, the sort of the logic or like everything, right? So yeah, that's the idea. So yeah, any questions in terms of this exercise before I actually move on to the next one? Okay, it seems like everyone has solved their question, I am assuming. Okay. Question once, question twice, deal. All right. Yeah. Okay, let's move on. So the third exercise is find the possible permutations. Yeah, I mean, you can do it by hand. I don't feel like doing it, so I would actually go on research because you know what, Python is really powerful um, in terms of this libraries, right? And those libraries, I mean, I am not against you to look up for those libraries as long as you know how to use it. Okay, yeah, Geek for Geeks is just a good website to get help with like all the programming stuff. And then I actually copied this code from them, to be honest. And then this idea is from iteration tools. It has a specific library, and then this is called import. So what import does is basically um, you have a function, right? Sort of this function or library, and then you just basically copy the entire function to your program so that you can use your function, right? So that is like include in C or C++, or I don't remember Java exactly, but I believe it might also be import as well. Yeah, I don't remember exactly, but yeah, the idea is similar. It just copies whatever you need to your file so that you can get access to it. Okay, so yeah, so if you provide if you call this permutations function with a parameter which is list, then you can just get all the permutations of this list, right? And then for I in lists perm print print I, then you'll get like those tuples out there. Okay, so yeah, every time you try to, yeah, there's also one for combination. So yeah, I mean, every time you try to try to build something, right? You can always check if someone else has already built it, because you don't build repeated wheels, right? 不要造已经有的轮子，对吧? Right? So that is sort of an important idea of programmers, right? As like but like if you actually have like different implementations and you feel like that different implementation feels better, or you know that it is most fit solution for your specific use case, then I mean, go ahead, develop your own solution. Everyone will be, enjoy, and everyone likes to see your effort. But yeah, if you have an existing uh, tool that you can use to get it very easily, go ahead, right? I'm not against it. So that is this. So permutation 1 2 3 is just like this. If you're interested, you can yeah. And if you really want to build it yourself, like, go ahead, feel free to do it. All right. So next exercise, write a Python program to remove repeated elements from a given list. So you have a sample input, which is a list. It can be literally any type. We can assume that there is no like nested list, so there's only one element. Each element is like either a string or um, a floating point number or integer. Right. So the idea is no. So first, you initialize a variable list called no duplicate, and then for I in duplicate means for each element in dupe, right? So this list, if I is not in duplicate, no duplicate, then you add it, right? Um, so right, I mean the logic is pretty clear. So if it is not in there, then you just add it. But if it is in there, then do nothing, right? So like don't add it into it, right? And then after you print, you will have a no duplicate list, right? So yeah, that is basically the exercise. So is there any questions, concerns? I am just gonna wait until 45 and see if anyone has response. And then yeah, one thing just occurred to me. I will make some comments on this last exercise, and then we're gonna actually move on to today's material. So yeah, uh, in terms of this, there is also a good way to do this, and this is called set. I will just introduce this to you, but you don't have to understand it right now. All right, but yeah, it is pretty similar. It is set is one of four built-in data in Python used to store the collection of the data. The other three is list, tuple, dictionary, right? Dictionary, we're gonna talk about it today, and then I am just gonna briefly mention set. Yeah, I think it will be mentioned more later in the lecture. So a set is a collection which is both unordered and unindexed. So that means that there is no order in this stuff, this set, and then there is no index for that set. And then you can use it using you can declare it using the square bracket. Not the square bracket, the large bracket, the large one. Yeah. So it has a feature that items are unordered, unchangeable, and do not allow duplicate values, right? And then let me see if you actually how to build a set. Yeah, so this, right? What you can try to do here is, for example, if you do this set is equal to set dupe, and yeah, see how that goes, and it should be print this set. It should be able to behave whatever is behaving. Yeah, here, look at those, how amazing it is. If you just use a set method, right? So you're basically like initializing this set using this method, and then you pass in a list that has duplicate in it, and then you actually print out this set, then the duplicate is removed, Okay, so yeah, that is the idea, and it is some wheel that people have done it before, but you can use both of the two ways as long as you understand what you're doing. All right, so yeah, that is the idea. And also, yeah, if you use this approach, don't forget that the sample output is still a list. All right, so you have to change this back. Yeah. So that is the comment that I want to make on set. Yeah. And we are actually gonna go into today's lecture. We are going to talk about dictionary, and after this we are sort of done or the basics of Python, right? So that is not too much. Okay, so in terms of this like basic stuff, I think we are pretty much done. And then the next step will be we'll talk about functions, right? How do you write a specific function to perform a certain thing? And then we're going to talk about objects, right? Objects-oriented programming in Python. It is a pretty important idea. All right. So yeah, in terms of dictionary, dictionary is the idea that you have a key and then you have a value. Sorry about that. This is actually reminding me PPAP. So yeah. All right. All right. Seriously. I have a key. I have a value. Then we have a key value pair. Okay. So you can access the value using this key. Okay. And what I mean by that is for example, you have a dictionary that is called scores, right? And then yeah, be extremely careful here. So the notation of dictionary is pretty different, or yeah, I would say pretty different in terms of like compared to the notation that we are using before. So we are declaring it as a using a large bracket, and then you can do like this is key. So key colon value, and then comma the other key, and then the other value, and then comma, so on and so forth, right? And then for example, in this case, you can do, for example, Chinese is equal to not equal to, but like column 89, right? So one key pair value is Chinese and 89, right? And then you know math is math column 94, and English column 92, right? So that could be like a specific mark uh, or like report card of a specific student, right? And you can also create empty dictionaries. That is allowed. Okay, so yeah, that is allowed. And then note that tuple can be a key value, but a list cannot. So for example, if you do this like bracket 20 comma 30, and then you do like good, or and then if you do 30 and column bad, then it is valid. But I don't personally have a lot of use case on that, as long yeah, so that is just for knowledge or just for your information thing, that this can be done, right? And if you have more use cases in your future programming life, then yeah, that existed, and that you can use it. Okay, so so you can have another dictionary like this. Oh yeah, this is a list of tuple, right? And if you use the method dict dictionary, you can convert this list of tuple into this dictionary. Oh yeah, just a reminder that for this specific notebook, it is highly recommended that you try to sort of look at my notebook and then try to write program yourself, right? Like you can try to come up with those kind of examples, because you know you might think that this is actually very easy, right? And then when you try to write the program yourself, then you might actually need to go up and look for notation, and that will significantly slow down how fast you program, right? Even though it is not required, it is that it is something, if you need to use very often, then you just you better keep it in mind. I would just make this comment. Okay, so yeah, back onto the topic. So yeah, you have a um, list of tuples, and then yeah, just be careful because it is tuple. So this is not column anymore, this is comma instead of column. Okay, and then everything here is comma. All right, so yeah, that is yeah, so as long if you call dict, then it will actually convert into a dictionary. Okay, you can also do like list of list, so that is also valid. All right, so yeah, you can have like this fancy car. I mean, yeah, if you're a good programmer, then you can actually buy those cars yourself. All right, so yeah, dictionary, dic 5 is you can just do a dictionary without actually passing in anything. Then if you print that, it will be an empty dictionary. Okay, so that is expected. Um, you can also do this. You can without passing any kind of lists or tuple, you can actually specify. So, for example, Spanish is equal to 1.39, and then cabbage is equal to 2.59. Like those, this is sort of like prices um, in Chinese vegetable market. But yeah, so like yeah, so it also makes it into a dictionary, and you can also create a dictionary like this. Okay, so that is basically different ways of how you create this dictionary. Okay, and then basic usage of dictionary: you can get the value using key, you can add the key value pair using key, delete the key value pair using key, change the key value pair using key, and then check if a specific set of key value pair exists. Okay, so yeah, as you can see here, it is sort of like using key, using key, using key every single time. So the key is pretty important for a dictionary, right? It is sort of like you have a storage room, right? Like you have, for example, you go into a swimming pool, right? And then you just put your clothes, or put whatever you bring into like a specific storage, I'll say storage case, right? And then it is pretty important for you to keep those key, right? And then you know, if you don't, then haha, uh, you have to go out there and naked and look for the keys, or go ask for help. But yeah, so that is what happens if you lose the key. So that is important that you keep the key, and it is the same for programming language. You have to know your key very good. So yeah, you can have scores. for example, in this case, Chinese is equal to or has the value of 89, and then you just print scores, and then you provide the key here. So the notation of that is actually using a square bracket. But in terms of like sort of indexing, you're passing in the key value, right? Notice here, this is not a number anymore, right? This is actually a string, and this is actually the key that you remembered, right? And yeah, so that is the difference between dictionary and list, right? And also tuple maybe. Yeah. So I'll tell you more on that at the end of the lecture. But yeah, that is something that you keep in mind of. Yeah, so you do print scores, right? And then you can add a specific item or a specific key value pair using this technique. So you can have score mass is equal to 93, and then here you don't have to be, it doesn't have to be a string, it can be a number as well, right? So you can do this, score 19 is equal to 91, right? And then if you print the scores again, then you can see, those two key value pairs are actually added in the dictionary. Okay. So, in terms of this, similar to a list or similar to any kind of stuff, you can delete a key value pair using this key. So you just delete scores, and then you provide this math here, and it not only deletes the key, it deletes entire entry, right? So even though you only call, for example, scores mass, right? And then it deletes the entire thing. It deletes a key and deletes a pair, right? So that is one feature of that. And then you can also change the value. Yeah, let me run each cell. Okay, so yeah, when you try to change this this value of existing key, then you can do that as well. You can do that as if you have never seen, or you can do it as if the key is never in the dictionary. Okay, so this is the same thing. Okay, so I have cars, right? And then oops, cars is not defined. Okay, yeah, I am just gonna restart the runtime, and then yeah, because I might forget to run some of the cells. What input? Okay, this is I am just gonna stop it for now. Okay. Yeah, so that is all the way until the end. I don't want that. Okay. So yeah. In terms of what was I? Yeah, so print cars, right? So cars right now is just a list of lists with like those information of the price, and then you can just do make it into a dictionary, and then this is right now is dictionary, and then you can have this in operator as well here. So you can print all the in cars. That means check if a specific key that is in the dictionary or not. Okay, so that is the idea, and that is frequently used of like how to access the data in the dictionary. Okay, so yeah, the future will be you can think of list as a subset of a dictionary, and what I mean by that is think of list is a dictionary with like all integer indexes, right? So like in terms of dictionary, you can use different you can have different things for key, right? You can have a string, you can have whatever you want for key. But in terms of list, then the key can only be like, for example, 0, 1, 2, 3, 4, 5, right? Like those integers, or I would say like natural numbers, right? And then yeah, that is the idea. And there is actually difference between different between dictionary and the list. So one difference will be that if you try to set a value for unindexed unexisting index in the list, it will give you an arrow. So in terms of this, right? For example, if you do score 19 equals to 91, but it will, if the score is not long enough, right? The scores are not already like 19 um 19 elements long, right? Then it will give you an error, like in string index out of not string index, list index out of bound, right? Like just be careful with that. Yeah, you can change the value, but you cannot add a value in list using this fashion. Okay, so yeah, and if you're curious more about the different dictionaries, you can actually use Python itself. There is a thing called dir function, and then if you call that to this keyword dictionary, then it will just give you all the kind of functions that is useful in there. Okay, and yeah, the method clear just means that clears the entire dictionary. So that is self-explanatory. And then get method. So get method is a better way to get the value of a specific key. In terms of better, I mean, the goodness about it is that if you use a square bracket, then if you're trying to access a key that does not exist, then an error will occur. So that means if, for example, shit. Yeah, so because I run, yeah, I run everything, so it has like memories already in that. So run all. Yeah. So if this is dictionary right now, and then you can do cars dot get BMW, and then BMW is 8.5. Cars get Ferrari, right? You might actually want a Ferrari someday in your in your house, right? But yeah, cars dot get Ferrari, and if you do get on a non-existing key, then it will just return none. But if you use this square bracket notation, then it will give you an error. Okay, and then the program will crash. So it will give you a key error for like this key does not exist in the dictionary. And I'm not saying that get is definitely better than the square bracket, because when we are dealing with dictionaries, a lot of people are just using the notation of square bracket. So yeah, just again, it means that you need to sort of be careful of the limitations of a specific thing, right? So the limitations of the square bracket is that you cannot try to access the key that does not exist, but you can try to add them. Okay, so yeah, that is the comment that I'm gonna made, and yeah, I'm just gonna run it again. So update, the function update just means that you can take a dictionary and then you can try to update both of those values. So for example, um, right now the cars is like BMW, Benz, and Audi, right? But if you try to update that using another dictionary, right? So you can have dictionary with like BMW is equal, is not like it has a value of 4.5. Ferrari has a value of 9.5, and then you can see the value for BMW is updated, and then the value for Ferrari is added, right? So this is the key, thing for updates. Okay, so yeah, in terms of items, keys, and values. So those are just functions that is built in dictionary. Okay, so I would do print cars.items, and then if I run this file, if I run this cell, then you can see this diction. Yeah, dictionary items, BMW, Benz, Audi, and Ferrari. And then if I print the type of that, it will be a class dict items, right? And then you can actually convert it into a list, right? Then you will have a list of tuple, right? And then you can actually, after you convert it into a list of tuples, you can access each element using that, right? So this is like a list of tuples, right? It is. It seems like it is pretty similar to this exercise two that we did. We just talked about it, right? Yeah. So that is that. Okay. So in terms of this, we also have print cars.keys, right? So cars.keys is just that do it just gets all the keys out there and then leave the value, right? So if you want actually get a list of keys, then here it is, right? So that is when we actually like go to reception desk and ask for a list of keys, and what are those, right? So yeah, you can do cars.keys, and then also you can do similar things. You can do cars.values, and then those are pretty much the same, and I'm not going to repeat myself. So yeah, print cars, and then you can do actually have a method called pop, and then you have to sort of pass in a parameter um, called Audi, and then you just do that, and then and the item, like the key pair value Audi, is now different. Okay, so yeah, and do not try to pop without any parameter, because sort of unpredicted thing will happen, right? When I mean unpredicted things, so I think it will actually pop, and then but you don't know which one that you're popping. So we can actually do a little experiment, right? So let me actually do an exercise, a little experiment. So I add a code cell, dict 4, and then I just print dict 4, right? And so here it is, PNW Benz and Ferrari, right? So what I do is print dict 4 dot pop. Oops, this is lagging a bit. Okay, yeah, it actually does not allow you to do that. So pop expects at least one element. And then, yeah, I believe there is a method called pop item, and then it actually pops you out some weird stuff. But yeah, don't use that. And if you want to specifically delete one entry, then you can just do, yeah, you can just do you can just do make that a specific entry into like a empty place, right, or an empty value. So yeah, or you can call delete, right? But yeah, pop item right now seems to be working pretty good, and but the idea is it is called a hash table or a hash map because accessing the dictionary value has the time complexity of O1. Yeah, this is when we talk about time analysis, we will talk about this specifically in terms of like big O notations and the time complexity of doing stuff. But yeah, so think of so for now, you can think of this. So if you are looking for an element in a list, what you will do? You will do for I in list a list, for example. Yeah, I don't have this kind of variable right now, but like, yeah, so like if I is equal to something, right? For example, if I is equal to 4, right? Print found, right? If you're trying to look for something in a list in a normal way, then you would cost you basically like just go through the entire list and check if that exists, right? And the length of that list will be the time complexity. But if you do uh, dictionary, and if you actually check out the time complexity for dictionary, it will be O1. What it means is that it costs basically no time to uh, look for an element in a dictionary. Okay, so that. I don't want to go into too much detail about it. I believe that with more context in the algorithm analysis chapter, then it will be better. Okay, so yeah, I'll just leave this for now. And if you're interested, search it out. Okay, search it up. And yeah, I'm just gonna delete this. Okay, so back into the topic. You can also use a dictionary as sort of a parameter for to pass in the string. All right, so you can see here the temp. The book name is and then you do percentage, and then you do bracket, and then this bracket is the key. Okay, and then you do percent s means this is a string, and then you do like percentage price, right? This price is also the key in this dictionary, and then you can actually format this, right? And when you run it, then you also define a book, mm, book dictionary, then you can use like name or Python exercise price, and is this, and then you pass in to the temperature, pass in that temp variable with the bug, um, as like parameters, and it actually does what you expect, right? So it just takes all the values from that dictionary, and then and then map it into a string, right? So that is another use case for a dictionary. And then yeah, so exercise, you user input n upper case letter, and then use dict to count how many times user input each letter. Okay, so that is the exercise. Let me actually check how much is left. Yeah, not too much is left. But yeah, you can leave this for now. Let me actually continue on the lecture, and then we will come back to the exercise at the end. And also, in terms of exercises, if I have time today, I will just go through those exercises with you guys. Okay, so I will, for example, give you 5 minutes to think about this question, and then I will just write out the solution. Okay, and then because yeah, today I am planning to give out an assignment. So yeah, I am just not gonna give you too much exercises to deal with. Okay, so I believe that sounds fair. All right, so yeah, so that is that for dictionary. So we are, I would, I would say pretty much done with the basics. I would make more comments on, the loop, or this is called flow control. And then tomorrow we're actually going to talk about like functions and stuff. Okay, so yeah, there is a stuff that I forgot to mention when I introduced you guys to you guys the loop. It's called pass keyword, right? So it is a placeholder. It does not do anything. Uh, I don't exactly know what is the reason it existed, but like it is just sort of like a placeholder. Yeah, so it just put it there. All right. So, um, for example, if you have a program like this, so input an integer, and then you take that integer. If that is larger than 5, you do greater than 5, and if you do less than 5, then it's passed, right? Else it is equal to 5, right? So, for example, I do 6, right? And it will print greater than 5. I print 5, I'll say equal to 5. But if I do 4, it will does nothing, because here pass does nothing. Okay, so that is just a pass. It is just there for a placeholder. You don't have to worry about it too much, because yeah, sometimes you will see it in those test cases, I would say, test files. But yeah, that is not normally used in our program. Yeah, assert keyword means assertion. Um, and if you do not understand assertion, it is like, make sure something happens, right? You can understand it like this. So for example, this is especially useful when you're dealing with user inputs, right? So you can say s age is equal to, like, please input your age. So I would say 20, for example, right? And then you just print reasonable. Okay, like if you do 9 years old, and there will be an assertion arrow. So if I put 9 and then the age is 9, right now the assert 10 is less than age is less than 80 is failed, right? So assertion arrow 9 is actually less than 10, right? So this assertion does not forfeit, then it will give you an arrow. Okay, so this is more used like in terms of testing your code or just to verify the user inputs. Okay, so in this case I'll just put 20. So yeah, reason. All right, and also use loop to iterate through a dictionary, right? So those are just the ideas that we have just talked about. And if you say I have a dictionary with this, classic ones, and then for key value in my dict.items. So this is interesting, right? This is sort of like unpacking, right? So yeah, check this. So for key value, yeah, I mean this is not usual in so many other programming languages. Like you have those two things, right? But like yeah, so for key value is like key is for key, and then value is for this value, and then you print key and then you print value, and then you get Chinese, and then value is 89, and then key is mass, the value is 93, and then those so on and so forth, the key pair like this, and then you can actually like iterate through the list, not the list, the dictionary, and you can actually do stuff with it. Okay, so yeah, you can also do a single thing with it. So like if you have key specifically you want to iterate through, then you just do for key, right? And then if you do vowels, and then you just do my dict dot keys or dot vowels, right? Dot values. Okay. So yeah, check how many times an element appear in the list. Okay. It seems like we have already it seems like the exercise is pretty similar, or I would say exactly the same as this one. So yeah, it's sort of thinking of you have a list, right? You have just different kind of numbers, and then you can have floats and strings and stuff like this. And then you have a dictionary, right? And this is the good use case for dictionary. It is like count how many times it is there. So for elements in source list, source code list, SRC list, and if element is in the dictionary, right? It basically means that the entry is already existed, right? So if the entry has already existed, then you just take the value of that entry and then plus equals to 1, because you need to increment the entry by 1 because you have found it, right? And else, that means the else case in this case means that the entry is not in the dictionary, so you need to add it, right? So you initialize it with 1 because you have already found one instance of that entry, right? And then you just print that dictionary, and then you can see 12 appears 2 times, 45 appears 3 times, as you can see. 3.4 appears 3 times, 1, 2, 3, and then crazy IT appears 2 times. Okay, so that is basically how you iterate through a nested it iterates through a iterates through a list and check if there is duplicates, and it counts how many times each element has. Okay, so nested loops. We have sort of have this idea already, and then yeah, in terms of nested loops, it's just loops in a loop. So what will happen is that, for example, when I is equal to 0, and you will get into the next statement, which is the next for loop. So when I is equal to 0, then j will equal to be from 0 to 9. So I is 0, j is 9, I is 0, j is 1, I is 0, j is 2, blah, blah, blah. And then after j is counted until 9, then you would increment I, which means I is now equal to 1, right? And then j just goes on and on. Okay, so that is the thing for nested loops. And yeah, think about this. We are printing 100 zeros. Yay! So yeah, as easy as that. So it is sort of like a 2D array, right? Or a 2D list. Like every time you are dealing with something that is two-dimensional, then you will probably need to so you will probably need loops that is nested, right? So you put like one loop nested in another loop. Then if you're dealing with three-dimensional data, which is like list in a list in a list, right? So you'll probably nest it 3 times, right? And then note that nested loop are pretty expensive, okay? Though they expanded with like exponential time. Okay, so yeah, just a reminder. Yeah, I am slowly just giving you guys a little bit information about algorithm analysis, but I just hope that through those ways, it will be easier for you guys to pick up this analysis. Okay, so yeah, nested loops just means, yeah, because if you iterate I 10 times and then iterate j 10 times, then the entire thing will be 100, right? That makes sense. 10 times 10 equals 100. All right, so that is the thing. So one line for loop. So this is more advanced technique. You don't have to do this, or you even don't have to know this. But if you want to write some beautiful code, or you're just lazy, you can do a for loop in one line. So basically what you can do is, for example, you have a range that is from 0 to 9, and then a list is x times x for x in a range. And then this, when it first comes to you, you might feel like it is really strange. It is what the heck is this syntax? So this means is that for every time you do for something, this for something, this something is that the one you create, right? And then this one that you create is just a iterator. When I mean iterator, it just means that it is equal to one value in this a range, right? And then it just move on again and again, right? So it is basically saying that for each element in a range, you perform that element times that element, which means that element square, right? And then you might think, this list can be really short here, and if Yeah, but at the end, if you try to print it, then you can see this is not this simple anymore. So it contains a list of data with like from 0 to 9 with its squared in it. And then yeah, just imagine like if the range is 100, um, this can be good. Yeah, if the range is 100, then this is pretty long. But yeah, that is the idea. That is quite long. Okay. Yeah, that is the idea. I'll just change this back to 10 to get symbolized. Okay, so yeah, that is the idea, and you can also do this. You can also have a condition there. So, for example, if x times x for x in range in a range, if x percentage by 2 is equal to 0, that means it is integer division by 2. That means it is even number. Okay, and you can also try this, and then yeah, I mean, you'll be surprised how easy Python code is, but the fact that with this simplified code, you can do a lot more. Okay, so yeah, that is all the material, like the course material that I have for today. Right now, we are going to exercises. Okay, as I have promised. So yeah, I will get you 5 minutes to try to run this or to write this program on your own. Okay, and after you try to write your program on your own, and then I am just gonna write it with you. Okay, so I will give you until like 40. Okay, yeah. So I will give you 40. You can first think of or think about how do we approach this question before we actually write the algorithm. Right. So yeah, time is up. So meanwhile, I just did those exercise myself as well. So as you can see, for example, I can assume that the read the user inputs 10 uppercase letter, or actually it doesn't actually matter how many uppercase letter that I put, right? Yeah, for example, what I can do is blah 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 blah. Okay, and then look at that. So I pressed A once, I pressed L once, press B twice, press J twice, like those, right? So it doesn't actually matter, right? So like a good program handles every corner cases, or like I would say every case for a specific task. And yeah, this is pretty similar to the code that I showed you before. But yeah, with a different logic, it is still working the same. So for C and S, which means a character, S in this case is already a string, and then you can also you can actually do iterating the characters um, with this method, right? So for C and S, C in here, because I use C for like character, right? So if character is not in count is just a dictionary. Yeah, so if that is not in count, so that is the first time it appears, so it equals to 1. And then else you do plus or equal to 1, so you have seen it already. Then you'll just output how many times that each letter is input. So yeah, after that, if you understand the example that I did today in the lecture, then this seems to be pretty easy. Okay, so the other exercise, write a program to combine two different dictionary. That is, I would say, yeah, I will give you like, I'll give you 5 minutes to finish both questions. Both questions needs 1 line of code or 2 line of code. Okay, so for example, you have a dictionary that is 1, 2, 2, 3, 3, and then dictionary B is equal to A um, B 2. Yeah, so something like this. Okay. Yeah, so yeah, just write a program to combine both different dictionary, and then get all the keys for dictionary. And I'll give you until 11:50. Okay. Yeah. So in terms of this exercise, what you can do is this. So you have dictionary A, you have dictionary B, and then you can do A dot update B, and then if you try to do this, if you try to access the value of this statement, then it will be none, because like the outcome of this statement is actually none, and then the value that is updated is already stored in A. So if you want to get print A, then you will actually get the correct answer. All right, get it? And then you can just, this one is easy. You can do A dot keys, then here, right? And then yeah, that is basically what it is. You can also just convert it into a list if that is what you want. List keys, right? So that is the same. So yeah, last 5 minutes. I will let you guys to deal with this exercise. This is the exercise for the if statement. A little bit for version control. Okay, and yeah, the last exercise. I will because there's I feel like this is not enough time for today. I will just leave you guys for homework, or probably I will add this question to assignment as well. So yeah, it will just be counted anyway. Okay, so yeah, if you guys can try to finish this exercise, it will be great. I will talk about it like in 11:57 or something. Okay. All right, so yeah, that is time for Check It Up. I'm still writing it, but it doesn't matter, right? No, that is equal. Yeah, and basically you are trying to ask user for the input of the mark, and then you're just checking if the mark is you know in a specific range, so that you can print the grade for example a student, right? Print D, right? So yeah, also you can also try to think of a way to assert this mark is an integer, because the mark is right now, you know, it is a user input. You don't know what the user will input. It is not you that will input usually if you're designing a system for someone else. So you cannot predict what they are inputting, but your program has always to work, right? So um, that is the reality for programmers. And yeah, you sort of have to assert the mark is from 0 to 100, right? So this is sort of an extra step, and this is like assumption for mark in general. And then yeah, if mark is larger or equal to 90, then print A, and then lesser or equal to lesser aleph 80. Yeah, mark is in the range of 80 to 90, then B from 70 to 80, then C, and then else for D, right? So if I run this program, I do like 96, and then I'll just give A. Oops, I run it again. 78. Give me C. Okay, so yeah, that is it for today's lecture. I am gonna post assignment as soon as I can. Hopefully by the end of today, maybe earlier as well. Um, but yeah, that is it for today's lecture. Is there anything that you guys want to mention, or you guys want me to elaborate more um, before we actually end today? Okay, there are no questions. No question once. No question twice. No. Okay. Yeah. All right. So that will be it for that will be it for today's lecture, and I will see you guys on tomorrow 10 a.m. All right.
Thank
All
you.
right. All right.
Bye.
Yeah.
Have a good
Bye.
day.
Yep. Have a good day. All right. Thank you. Bye. Yep. No worries. See ya. Does our assignment have a due date? Um, I am thinking about it. Maybe the end of the week, or I might. Yeah, yeah. By the time that I give out the assignment, I will give you a time, but like definitely not tomorrow. I'm not expecting you guys all to finish tomorrow. So yeah, don't worry about that. And yeah,
And hi, Ray. And
yeah.
yeah, I believe for the assignment and or even some test or quiz or whatever, so our final project.
Mhm,
So I know some students they must have. So, but
mhm,
some students if you don't need the credit, I think that's like just for fun. That's fine.
Okay.
So yeah, but it's a way to check your completion of this course, right? So you can know like what kind of level you are. And I believe so. Sometimes when you finish the course, you want to know what kind of level you are there. So I believe so. If you feel comfortable, you just do it. If you like if some students say, hey, I'm gonna go to your university, I just want to have fun, and then that's fine, then that's okay. Okay. Yeah.
Yeah. Yeah,
Yeah.
definitely.
Yeah.
That's good.
Yeah.
Okay. Yeah. So as you guys heard from Jennifer, that is the policy. If you guys do need the credit, then you have to do this. But no, then it is just a good practice. All right. All right. So that is it for the end of today. If there is no questions, feel free to leave. I will just wait for a few minutes if you guys are, busy typing. Okay. All right. Bye. Yeah. See ya. See you all tomorrow. Okay. See you all tomorrow. Yeah. If there is no questions, I'm just gonna conclude the meeting.